6.7. Yeah, times 2.4 times 2.
No!
You must have done that. Put that in the bottom.
Oh my goodness.
What about the bottom part? Or the 6?
No, not yet. Oh yeah, you squared. You squared.
No, 660.
What did we do to the distance in that problem?
We squared it.
No. No, what was the change in the problem? Do you remember?
Oh, half.
So what was changed? The masses, the distances, what's going on? So would you be a, what are we going to replace that d by?
0.5 squared.
0.5 d.
Oh,
So we'll put that in.
why wouldn't we square it?
We're about to.
Okay.
I'm just replacing the d. 0.5 d, the whole thing squared.
Oh, okay.
So when I simplify what's in the bottom, what do I get?
0.25.
And then here,
D squared.
you see how this
20.
looks
Oh,
like
that's
this, which equals this?
40.
So we can replace that by 40. And so
Okay.
now you need to just figure that out.
Thank you.
Thank you.
And now that you move this exponent over 1, there's a 10 here, the negative 1 power. And when they're next to each other, you add them. Since it's negative, it's basically subtracting, which gives you a power of times 10 to the 4th. That's it. Here.
Good. You have any questions?
No.
Okay.
Thank you. I got
Yes, you're almost there. Write that in scientific notation. What's 0.95 in scientific notation? No,
four.
no. Yes. How'd you get 4? That's right.
Because the decimal's over here,
Yeah.
and you have to minus 1.
Yeah. Yeah. You're done.
Okay.
Nice.
7.
I just made
10 to the negative 7 power.
If it's 1/2, is it 1.5?
There's A.
Okay, so 40 times 0.5.
No. Point,
Okay, so 40 times 0.5.
no. 0.5 squared.
No, I think
0.5 squared is 0.25. Oh, this is A. This is B.
5? How?
Let's just say round to the nearest 100.
Apparently, I only did one question.
Bingo.
Well, because I got confused with number 2.
Add them? Or we divide them?
No, you subtract them, remember?
Wait, so what
Did
is
you write the rules down from yesterday? You know, do you have them?
Was it the gravity workshop?
No, so these were extra rules that she said would be best to write down. I kind of have the color coded.
No, I don't have one.
They're really helpful.
I'll copy them and pass it.
No, to erase my answers again. Hate that. A. B. 4. I missed one.
Because the answer is 9.5
Tons?
10 to the I got 0.95 times 10 to the 5th power.
You're supposed to
Do you?
Are we able to edit a response?
Yeah.
Dr. Trina, could you refresh?
Are you leaving again? Yep.
Yeah.
You know the second one when it says that the force equals 40 and then the distance had been divided by about 1/2. It's 0.25 times 40, right? And it's 10.
Because 0.5 squared. Wait, I'm trying to. Because the answer, I'll give you the answer. You have to try to find out. It's 160.
160? That makes no sense.
Okay, so I'll give it to you in number sense. Okay, so 1/2.
Right.
You're gonna have 2 40s. Okay, so like one total length is 40.
Yeah.
You cut that in half. There's 2 40s. Think of that. Now you gotta square the 1/4, 1/2, which will give you 1/4. So it'll give you 4 40s. 40 plus 40 is 80. Plus another 40 is 120. Plus another 40 is 260.
But why do you have 4 of them, even if just because the distance is
Because
split in half?
it's getting closer together, so it's gonna change the proportion. Because like the way she's teaching us, it's getting you away from a different. It's a proportion teaching. It's really
Okay, team, send someone up. We're going to talk about the rubric kind of in general right now. In this section of the rubric, which Banks is stamping, you're adding planet orbits to your Geometer Sketchpad file. You're going to have one planet that's completely in the habitable zone, one that's partially in, partially out, and one that's fully out. So 3 planets. Okay?
3 of our same planet but different locations.
Yeah. So you're going to end up with 3 different orbits
Does it matter
around your sun. Huh? Well, you have the habitable zone graphed already, right? So one is going to be, if you look at read the criteria carefully. In general, one is going to be completely in your habitable zone. One is going to be somewhat in, somewhat out, and one is going to be completely out. Okay. Then I cut that graph goes with this table and the contents of this table. So there's no sense in starting this until this is done.
So what was that 2.8?
I have it colored like this. So you see how the colors match? So all of the things that are the same color as these rubric criteria, they go together. We need numbers from here in order to do these calculations. I colored this off to a side because in theory, technically you need to see the orbits to make the argument, but you can kind of reason this out. Of the 3 planets I described, which one will be the most likely candidate for life?
The one in the habitable zone.
Right, so even before it's graphed, you can write a paragraph on why that's the most appropriate and why the other 2 are not. And don't just say because it's in the habitable zone, explain what that means in terms of the conditions of your planet. This is independent research. You don't need, someone else can do that while other people are working on the sketchpad drawing. So you can get those stamps even if your ellipse isn't working. And this you can do like yesterday, because that was part of the workshop. So those are some easy stamps that you might want to go for if someone else is working on graphing those ellipses.
Wait, for that one, for 2.34, can you just show our work, like just show the example?
You can do it by example, or you can just explain it from the equation. You're just explaining how mass and distance impact the size of the gravitational force. So there's more than one way to explain that. 2.1 and 2.
2.21 and 2.22.
Yeah, these go together. Wait.
Oh, what if we wrote them a separate paragraph?
Oh. This is more about your solar system in general. This is more more zooming in on the one planet that actually works. So I would think of them as separate ideas. Any other questions about the rubric?
Which one was about the solar? Like you.
Huh?
2.21.
2.21. So the one we talked about was 2.21, which is we have these 3 planets. This is the one just by looking at orbits.
22 is
This is more
into detail.
Yeah, this is more specific to the one habitable planet. Give me at least 5 characteristics based on research that make that planet a likely candidate. And since you probably have talked about the habitable zone here, get creative. Do something other than habitable zone. Okay. On this one, here's what I've told people that got stuck on this. When you're selecting your planet masses and planet radii, it's okay to use our solar system as a template. We know that Pluto is a debatable planet. Sometimes they put it, sometimes they call it part of this belt of comets. Sometimes they call it a planet. I don't know. Every time I check the news, it's different. But we know at least that part of why they're arguing is because it's so small and so far away. Okay? So you might want to set that as a lower limit for your mass and your radius. And then we know what the biggest planets in our solar system are.
The sun.
So you might not want to make your... I'm going to pretend I didn't hear that.
Just go away.
No, don't go away. So if you're not sure what to use, you can use that kind of to get an idea of what sizes are right. But, okay? But don't exactly use Earth's mass, because I did that calculation already. That's boring. Do something different. Okay? One thing that's different also is I made it less calculations in this table. Initially, I was having you calculate the gravity here and here. Now we're just going to calculate it here for all your planets.
Okay.
That's the closest space. Okay? And if you don't know how to define this distance, come talk to me. If you're going for proficient, you're just going to do the distance between those. If you're going for advanced, you're going to include the radii of your planet and your star in that calculation. Okay?
Okay.
So when you get there, if you don't know what that means, come talk to me. Any other questions on the rubric? Okay, Banks, if you're stuck on drawing your ellipses, Banks is about to do a workshop on how to get that started.
Orbit comes within a star diameter of the two boundaries. So that means the inside and the outside. Wow. An easy way you can do that is you've already picked a point that's right here. Pick another point that's right there. When you find the middle of that, that's the middle of your ellipse. And then the distance from that to your star is your C. So then you already have your major axis, which is your A, and your C, and you just have to calculate your minor. Hold on. Completely outside. You have the completely outside. That one's complete. Let's say you have that one complete. Okay, don't have that one yet. So after you finish with that, you can just do a screenshot and put that in your presentation. Okay, third period. How many of you are having a hard time getting started on your ellipses? Okay, send one person to the front for a workshop. So your star, you don't have to write this down, I'm just walking you through this, is going to be one of your focal points. And then you're going to have some other focal point.
The center of our star or any point?
The center. Whenever I say star, I'm talking directly about the center, unless I mention something else. Okay, so if you find the midpoint between them, that's the center of your ellipse or your planetary orbit. So for example, like the Earth would be here, orbiting around. Okay, so how do you find all that stuff? Let's talk about it. Okay, I changed these just so it's easier for us to get something that works. But let's say, for example, this was your solar system, and you have your star in the middle, you have your two planetary orbits. So we need to get our orbit inside of there, inside the habitable zone.
Okay.
So what we need to do is we can figure out a few different ways. You have three things, your A, B, and C. A is your major radius, B is your minor radius, and C is the distance from your focal point to the center of your ellipse. You're going to make up two of them, and you're going to calculate the third one so that it works. Okay? So when I look at this, okay, if here's my star, if I want a horizontal ellipse, I'm going to pick a point. I can either pick it over here or over here, wherever I want. I'm going to pick a point, and just to show you how it might work if you're doing it, I'm going to have you make up a point. So make up some point.
10, 10.
Okay, if I do 10, 10, is that a good for our ellipse?
16, 6.
6. Negative 9, 6.
Negative 9, 6. You want this as your focal point? Okay. So maybe we don't know what we're looking for in our focal point, so I'll make one up for you. Okay, so here's our focal point 1 at 4, 6. Yes?
Yeah.
So I need another focal point. I'm just going to come over here, let's say, to 8, 6. No, your orbit has to be in the habitable zone. Your focal point, obviously one of these focal points is not in the habitable zone. The star, the center of your star is one of your focal points, which is not going to be in the habitable zone.
So that's not a part of the habitable zone?
No, your focal points don't have to be part of the habitable zone. Okay, so if this is a focal point and this is a focal point, where's the center of my ellipse?
In between.
Okay, so I average those two. It's a horizontal ellipse where it's wider than it is tall, so that means they're going to have the same y value. My y value is going to be 6. My x value is averaging these two. So 4 plus 8 is 12, divided by 2 is 6. Question so far? Okay, so that's the center of my ellipse.
Small ellipse.
Okay, so from that,
Are these just random?
no. Oh, those sort of, not completely. So HK is the center. So that means my center is at 6, 6. Okay, so the next thing I need to know is if I already have my center and I know where my star center is, what's the distance between those two? And that's what? It's my C. So my C value is 2. Did everybody see? No, doesn't have to be. Because even though you have small focal points, you can have, you can change the major radius to be whatever you want. Okay? Yeah, and that's going to determine the minor. Okay? So we'll put something together and see if it works. You could be right. I maybe should do, oh, by the way, on yours, make sure your C value is at least 50. Because if it's smaller than 50, it's going to make it, your A and B values are going to be really close together. They're going to be similar numbers. Okay? Okay. So how do I pick what I want my B value to be? I'm going to pick a point that I want it to go to. So for example, I might want my B value to go to 18. Okay. So if it goes to 18 and it starts at 6, then what's my B value?
14.
Okay. What?
No. I don't know. 12.
So what's 18 minus 6?
12.
Okay. So we have a B value of 12.
Good job, Bishop. Almost had it.
Okay, so what we've done so far is we have picked our second focal point, which in turn tells us where our center point is, which in turn tells us our C value. So we picked all of that. Then we decided where we wanted our B value to be. We've picked 2 out of the 3, so that means we need to calculate what A is. Okay, so A squared equals B squared plus C squared.
Not Pythagorean.
No. The letters are different from the Pythagorean theorem. It's the same concept as the Pythagorean theorem, but it's not a triangle. They're arranged differently. Okay, so our A value we don't know. Our B value is 12. And our C value is 2. Okay, so then, yeah, you would take the square root of that.
Oh, you would put 12.
Okay, this is the center of our star, right? We made up where our other focal point's going to be, right? Because it's horizontal, they have the same y value. So this is something 6, something 6, something 6, okay? To get this center value, we already know the y value. To get the x value, you add the x for these two. So 4 plus 8 is 12, divided by 2 is 6. You're just averaging those x values. So now we know our center point, okay? And that's where we got the center is 6, 6, okay? From there, this one, Connor just said, let's go to 18. Why did he pick that? Because it's far enough away from the circle that when we do our ellipse, it shouldn't touch it. So it should be okay. So let's say, for example, he could have picked maybe 16 and a half. That would have been enough to get past this. So we know our C, we know our A. Actually, we are pretty much finished. We just have to plug this in and see if it works. Okay, so according to our equation, we've got K, which is 6, plus square root of B squared, which is 12.
Where do you get 12 from B?
Where do we get 12 from?
Oh, yeah,
Because we said it was 18. So we know 12, and then we've got 1 minus x minus our h value we said was 6. And then we've got our a, which is 12.17. Okay, does that look like the equation here?
Okay, never mind. I go.
Okay, so does that work? Whenever you get that where it doesn't look like a circle at the end, just go into Properties and Plot and change that 600 to 10,000. It samples more, so it actually is more accurate. See how it comes close, but it's not there? So this would work as an ellipse, and I would do the negative. I would take this equation, and I'd do the negative to get the bottom half. So 270 squared, and then take the square root of that, and then 270. That's why. Because you didn't calculate it. So, you see how I got, so it's going from 10 to 50, so your C value is 40. Okay, so you do 40 squared, which is, you can't see it here, but it would be from the center to your star. Okay, so 40 squared plus your minor radius, which is 270 squared, is supposed to equal your C squared, your major, or sorry, your A squared, which is your major radius.
So it needs to be 30 instead of 40.
It has to be 272.94.
There's a few ways you can do it, but yeah, that would be the major according to these two numbers you have right here, if your star was going to be one of your foci. Okay?
It has to be, right?
Yes.
So you have to do the A, B equals C thing?
A squared equals B squared plus C squared. Okay, so since that one's wrong, I'm going to let you double check these and fix those before I check them again, okay?
That is a good description of the habitable zone. I want you to just kind of touch on, once Ellen has all the orbits, what that means.
Yeah, I don't have that because he's not.
Okay, so you'll finish that when he's done, because for some of the orbits might be too close to your star, so you'll know it's too hot.
Yeah.
Some might be too far, so you'll know it's too cold, but that's a good start. So I'll give you like partial for that. And almost full credit for that one, just add another characteristics.
Okay.
Yeah.
For life or for the planet? For life.
For the planet, like what are some conditions on the planet that will help it so that these things can happen? Yeah.
Forever do one.
But your star is centered at 0, 0.
Yeah, the star is 0, 0. Yeah.
So if you're going for advanced, you need to have.
advanced. I just want to get this done.
You're gonna skip all of those. It's
If I have
really
time,
just
I can
changing
get
your
it
center.
different. Just changing the center?
Yeah, that's the difference between advanced and proficient. So you should be changing all of your centers to some other value.
I'll make it 4, 4.
Okay. So anyhow, wait, something's very wrong here.
What?
These are all really tiny. That's not your habitable zone. Your habitable zone should have a huge radius.
That's what I got.
That's astronomical units. You need to convert it into solar.
It got really big.
Yes, it will.
Okay. It's just like...
It's
it
so
was
big that
really
you don't
big.
even really see your star when you zoom out to see your orbits.
Well, I thought
Yes.
it was wrong.
No.
So it was right?
Yes.
Okay, well...
You need to change those.
Okay. I'll show it to you tomorrow.
Let me look at your ellipses just to see what you're... Oh, well, that's going to change based on your... but what you're also going to have to do is... So, for example, from right now, from your center to your... Wait, where's your focal...
The focal point, it's right here. 1, 1. Or no, it's 2, 2.
No, it's not.
No, it's not. Here's 1, so that's the center.
Well, you're... Okay, so for one, this looks like it's centered around your star instead of the star being a focal point. This should be shifted over. Do you go to the workshop?
Yeah, I just forgot it.
So, yeah, the
move this one
distance
over
from the like if this is the center of your ellipse right now, it shouldn't be. This should be shifted over, so this is one of your focal points, and then the center gets shifted over.
Okay.
And the distance between that star and the center should be your C.
I think I just moved it because it looked wrong, but it's not wrong.
Okay.
Okay, so I'll make it real. It's just that it went really big, and I thought it was wrong, so that's why everybody else's was like really small.
Maybe because they were zoomed out already. I don't know.
Well, because it went all the way to like 200 and something.
Yeah,
Okay,
it will be. It's
I'll show it
big.
to you tomorrow.
Okay.
We're leaving now.